Abbas, please, Mr. Abbas, please mute every other person.
Okay, ma.
Mute them except you and I.
He's not talking, just smiling.
So this morning we are looking at data representation in computers. We are looking at data representation in computers. Now, first of all, what is data? Can you see my screen? Just chat me, say yes or no if you can see my screen. Yes, okay, good. So let me go ahead. I'm happy you can see my screen. So we are looking at data representation in computers. Data representation in computers. This is week 6. First of all, let's find out what data is. Can you see my screen? Just chat me, say yes or no if you can see my screen. Okay, I think I need to mute my YouTube. Yes, okay, good. So let me go ahead. I'm happy you can see my screen. So we are looking at data representation in computers. Data representation in computers. This is week 6. First of all, let's find out what data is. Can you see my screen? Just chat me, say yes or no if you can see my screen. Okay, I need to mute my YouTube page. Because I can hear the echo. I'm happy you can see my screen. So we are looking at data representation in computers. Data representation in computers. This is week 6. First of all, let's find out what data is. Can you see my screen? Just chat me, say yes or no if you can see my screen. There's a problem.
Ma, the YouTube link has been created. I've sent it to the chat group.
Yes, I know, but I'm hearing my own voice, so it's echoing, and I'm trying to close the page. You get what I mean?
Go to YouTube. You can click.
It's echoing, so that's why I've stopped talking, because I'm hearing everything I'm said repeatedly. It's repeating myself. So I'm looking for the page, and I have so many pages open. That's the issue. So I don't know exactly which one is that YouTube page now to close mine. You get what I mean?
Yes, ma'am.
Channel dashboard. Okay, I'm on YouTube page. So how am I going to...
You would see, if you click on the video, you will see an icon, like a speaker icon. So just click on it and it would stop echoing.
Mm-hmm.
If you put your mouse over the video, you would see like a small speaker icon. So please, guys, help us forward the YouTube links to your other colleagues. Can you stop sending messages to the chat group temporarily so I can post?
My problem is, look,
Please stop sending messages to the chat group. Let me send the link so you can forward it to your colleagues or your classmates.
I'm trying to close all the YouTube pages here now on my screen because there are so many pages opened. So because I don't know which one is exactly the one that is linked to this. So closing all my YouTube pages. Okay, live stream. Okay, I think this is it. Close. I don't want to be part of the YouTube section.
Forward the link. Forward the link to your colleagues.
Okay.
Please, don't let them miss out on the lecture.
Okay. Okay. Are you seeing my screen?
Yes, it is visible.
Okay, so yeah, I think it's better now. There's no more echo. Data representation in computers. That's the topic we're looking at today. First of all, what is data? Data refers to the symbols that represent people, events, things, and ideas. Data can be a name. Data can be a name, a number, the colors in a photograph, or the notes in a musical composition. That is just the basic definition of data, symbols, observed facts, things you see. Now, data, what is data representation? Data representation refers to the form in which data is stored, processed, and transmitted. Data representation refers to the form in which data is stored, processed, and transmitted. In order to store the data in digital format, we can use any device like computers, smartphones, and iPads. Computer does not understand human language. Any data such as letters, symbols, pictures, audio, videos, and so on, etc., fed to a computer can be converted to a machine machine language first. What it means is that computer does not understand human language. Any data you put in, any data such as letters, let's say your numeric numbers, your alphabet numbers, like when you type characters from your keyboard, symbols, pictures, audios, videos, these are all types of data that you feed into your computer. It is converted to machine language first. Now, how does computer represent data? Computer represents data in three forms. One is number system. One is number system. That is, if you have numbers, there is a way it is represented. Numeric data contains numbers, which helps us to do arithmetic operations. Now, we were introduced to the concept of numbers very early in our lives. So to a computer, everything is a number. Alphabet, picture, sound, and so on. They are all represented as numbers. So the digital devices represent numeric numbers using the binary number system, also called base 2. The binary number system can only have 2 digits, zeros and 1. That means all this your data, which is like text, pictures, audio, videos, they're all converted into binary numbers, which is in the form of zeros and 1. There can't be any other digit like 2 in the system. So when the computer converts it, it converts your data, which is pictures, text, videos, sound, into binary digits of zeros and 1. That is the form in which it is represented in the computer. Now, number system is categorized into 4 types. We have the binary number system, which I've just explained. We have the octal number system, we have the decimal number system, we have the hexadecimal number system. So these data, which are pictures, objects, video, sound, are converted into any of these four formats. The binary numbers are in the forms of zeros and one. The octal number system represent values in 8 digits. Look at this, you will see in the binary system here is represented in the forms of zeros and one. The octal system is represented in the forms of 0, 1, 2, 3, 4, 5, 6, 7. The decimal system, which is what we use in our normal lives, is represented in the forms of 0 to 9. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the hexadecimal system is represented from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A is 10, B is 11, D, and so on, up to 15. Now, what do we mean by decimal system, binary system, octal system, and hexadecimal system, the forms in which data is represented in computer? Decimal is nothing but the number we use in our daily life. Whatever we write in our daily life, it is represented in the form of, whatever number we write in our daily life, we use the 10 digits, 0 to 1. When we are writing numbers, we write 1, 2, 3, 4, up to 9. And then 10 is a mixture of 0 and 1. 11 is a mixture of 1, 1. 12 is 1, 2. 50 is 5, 0. What we're saying is that all numbers are built from these fundamentals, which are 0 to 9. They are all numbers, no matter how lengthy, are a combination of these basic numbers of 0s to 9. Now, since we can use one or some of these 10 digits in decimal, we can say that decimal is having base 10. Now, binary system. In digital electronics, we write the numbers using only the digits 0 and 1. Whatever number we have in the normal form, which is in decimal form, it can be written in digital electronics only by the digits 0s and 1. That means the normal numbers we have, like our 1, 2, 3, up to, let's say 1 billion, whatever, can be converted into binary equivalents of 0s and 1. So I will show you, there's a way we do this conversion. There's a way we convert, let's say 50, 100, any numbers. There's a way we convert it to the normal decimal. Our normal numbers, I said, that we have been using from primary school, from when we were born, which has always been the decimal format. Like our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up to say 100 or 1 million. As we call them, as we mention these numbers, they're already in the decimal form, but we don't really say it. We can convert any of these numbers into binary. We can convert them into octal or hexadecimal, and you can convert from octal to binary, from octal to decimal, from hexadecimal to binary. You can interchange. You can change from one form to the other. Octal is nothing but the number we write using the digits 0, 1, 2, 3, 4, 7. And the hexadecimal is nothing but the number to write using the 16 digits. It's from 0 to 1, 2, 3, 4, 9 to 9, and then A, B, C, D. Look at it. A is 10. B, when you get to 9, the next one is A, which is now 10. B is represented as 11, C 12, D 13, E 14, and F should have been 15 here. This should be 15. This 15 should be 15 here. Okay. Now, whatever number we have in irregular format, it can be written in the hexadecimal. What I'm saying is that we can interchange. You can change the numbers from one number system to another number system. Look at this table. This one is in base 10. This is the one I've been talking about, 0 to 9. Look at 0 to 9. And then we have 10, which is a mixture of 1, 0, 11, mixture of 1, 1, 1000. This is the binary equivalent. Look at the binary equivalent, which is a base 2. You can see 0 here is the same as 0 here. 0, 1 in base 10 is the same thing as 1 in base 2. 2 in base 10 is 1, 0 in base 2. 3 is 1, 1. 4 is 1, 0, 0. 5 is 101. You can see that in base 2, which is this binary format, the numbers consist of just zeros and 1 in different arrangement pattern. As you can see, it's made up of zeros and 1 arranged in different patterns. So you can see, look at 1000 here. In binary form, it's 1, 1, 1, 1, 1, 0, 1, 0, 0, 0. You can see. So in the binary form, it's just a mixture of zeros. So this is how data is represented in the computer. using the number system. Now, another way in which data is represented is text code. Text code. Text code is a format used commonly to represent alphabet, punctuation marks, and all the symbols. Text consists of character data, which can be formed with the help of symbols, letters, and numerals, but they can't be used in calculation. You know, for numeric numbers, the first case now, number system, they're used for calculation. But for this one, text code, we can't use it for calculation. It consists of alphabet, you know, characters, punctuation marks, and other symbols. So using the character symbol, we can form our address, like say Lagos, Ibadan, Pangrove, or Jota, air color, red, green, blue, name, Roselyn, Abbas, Ronke, Abdullah Sisi, Mohammed. So these are all text. Now, this is an example of the text code. Some types of code are employed by the digital devices to represent the character data. So some types of codes are employed by digital devices to represent character data, that's text code. So we have the types of code that we use to represent data. This type of data include Unicode, ASCII, and other types. The popular ones, 4 popular ones are these: EBCDIC, extended binary coded digital decimal interchange code, extended binary. The E is for extended, the B is for binary, the C is the coded, the D is the decimal, the interchange code. So this one is an 8-bit code that defines 256 symbols. So below is the EBCDIC tabular column. This is it. You can see it. I told you it's used to represent alphabet. Look at A here. It's represented like this in your computers. Look at B. It's represented by 1100000010. C is represented, and then see the special characters. You see? See how it's represented in computer. So if you just type this, let's say less than symbol or plus symbol in computer, what you have is it is represented in this mixture of zeros and one. Okay, so this is how it is represented in your computer. Just one small symbol is represented with so many characters, which is a mixture of zeros and one arranged in different patterns. Now, ASCII, with the help of, I'm here now, ASCII, with the help of telecommunication equipment, computers and many other devices, with the help of telecommunication equipment, computers and many other devices, ASCII code can represent the text. The ASCII code needs 7 bits for each character. That means each character takes 7 bits. A bit is the smallest form in which data is represented. A bit is like this 0, 1, 0. This first character says 0 is a bit. Okay? The ASCII code needs 7 bits for each character, where the unique character is represented by every single bit. For the uppercase A, the ASCII code is represented by 10000001. Okay, look at the ASCII code here for this. Look at this null prompt. Look at the character like null prompt. Null prompt is represented in decimal as 0, but in ASCII code is represented like 0000000 in 8 places. Head of starting is represented by 1, but represented than this in computer. You can see these are all characters represented. Look at inquiry is represented like this. Backspace is represented like this one here. So these are forms in which character is represented in computer. We have another type of code, which is extended ASCII. Extended ASCII can be described as a superset of ASCII. The ASCII uses 7 bits to represent a character, but the extended ASCII uses 8 bits to present each character. The extended ASCII uses 7 bits of ASCII characters and then 1 bit for the additional character. You see, the extended ASCII, which uses 8 bits to represent a bit of ASCII character and then 1 bit for the additional character. Okay, using 7 bits, the ASCII code provide code for 128 unique symbols or character, but extended ASCII provide code for 256 unique symbols or character. Another type of code here is the Unicode. Unicode is another format in which data is represented. Unicode is also known as the Universal Character Encoding Standard. Unicode provides a way through which an individual character can be represented in the form of web pages, text files, and other documents. Using ASCII, we can only represent the basic English characters, but with the help of Unicode, we can represent characters from all languages around the world, as it uses 16 bits and provide codes or 65,000 characters. You need to know the number of bits each of these takes. Unicode uses it to represent a character, and it provides codes for 65,000 characters, while extended ASCII takes 8 bits to represent a character, and ASCII takes only 7 bits to present a character. Please take note of these small differences between this format of representing character using this text code format. I've mentioned that character data is represented in 3 formats. I mentioned the numeric format, which is this one here. Using the numeric system, they are sub-categorized into 4. We have the binary system, we have the octal system, we have the decimal number system, and the hexadecimal number system. These are the formats in which the character is represented, that is numeric numbers. It represents it in 4 ways. But for text format, for textual characters, it is represented in this format using these 4 text systems. It is presented using these text code systems: EBCDIC, ASCII, extended ASCII, and Unicode. And you should know how many bits each character, how many bits are in each character. You understand me? Unicode, pronounced Unicode, uses 16 bits and provide codes for 65,000 characters. This is a bonus for representing the alphabet of multiple languages. Okay. What else? Okay, take a look at this. Presenting text. This is Unicode. Look at space. It's represented like this. Look at 3. It's represented like this. Look at F. It's represented like this. Look at Y. It's represented, and then I. So look at how it's represented. This is how this example of how text is represented in the computer. How many bits are here? Let me count. 3, 4, 5. These are 8 bits. These are 8 bits. So this might likely be extended ASCII that takes 8 bits. Yeah, this is 8 because the ASCII takes 7 bits itself. It represents character data in 7-bit format. Okay, this is the extended ASCII. Now, remember when you are representing numbers either as decimal, binary, octal, hexadecimal, you can convert from one form to the other. You can convert from binary to decimal, from decimal to binary, from decimal to hexadecimal, from the octal to hexadecimal. There is a way we do that. I have, let me see if I can get that one now. There's a way in which it is. I have a link I have to show you how the conversion is done. I saw it. They said I was going to show your class. Not this page. Okay. Now this one is converting from, what am I converting from now to what? Decimal to binary. Let me convert from, let's see. Binary. Okay, I need to share the screen. Can you see my screen? I have moved to something else. Let me share this new screen with you. Let me share my new screen. I want to show you the conversion from decimal to binary. So we can convert from one number system to another type of number system. Can you see? Please, can you see this? Can you see decimal 41? Division, quotient, remainder?
Yes,
can you see?
They're responding.
Yes. Okay, thank you. Now, let's say 41. Let's say I have decimal number 41 and I want to convert it to binary. So what I do is that I divide by 2, I get 20, remainder 1. I divide the 20 again by 2, I have a quotient of 10, remainder 0. I divide the 10 by 2, I have 5, remainder 0. I have 5, I take the 5, divide by 2, I have 2, remainder 1. I take 2, divide by 2, I have 1, remainder 0. I now take the 1, divide by 2, I have 0, remainder 1. So if you move down, up, the way this arrow is drawn, you pick 1, 0, 1, 0, 0, 1. So that's the binary equivalent of 41. Okay, so that's how to convert from decimal to binary. Now let me convert from binary to decimal back. Let me convert from binary to decimal. I want to do the reverse operation now. It's not coming up. Why? It's my data. My data is connected. It's not coming up. 1, 2, 3. It's quite simple. Let's say I want to convert in the opposite direction. You know, I've already converted from decimal to binary. Let's say I want to convert from binary to decimal back. So look at this number. I want to convert from binary to decimal. I have a binary number of 100111011. I want to convert this binary number to decimal. So how do I do it? If you start from the left-hand side here, you raise this one. You know, this one, if you count, let's give this one 0. You give this one 1. You give this one 2. You give this one 3. From right, you take it leftwards. Now, so it's going to be 1 times 2 raised to power 0. Then this one will be 1. You take this second one, number 1 times 2 what? Raised to power 1. You know, you take an index of, your index starts counting from 0, right? It counts from your right leftward. So this first one will be raised to power 0. This one will be raised to power 1, raised to power 2. So we've done for the first one raised to power 0. We take this 1 times 1, 2 raised to power 1. We take 0 times 2 raised to power what? 2. We take 1 times 2 raised to power what? 3. This one will be 1 times 2 raised to power what? 4. 0 times 2 raised to power 5. 0 times 2 raised to power 6. And then 1 times 2 raised to power 7. So what do? We add them all together. Now, 1 times 2 raised to power 2. You know, 2 raised to power 2 is 1. So 1 times 1 is 1. 1 times 2 raised to power 1 is 2. 0 times anything times 0 is 0. 1 times 2 raised to power 3 is 8. 1 times 2 raised to power 4 is 16. 0 times 2 raised to power 5 is 0. Anything times 0 again is 0. 1 times 2 raised to power 7 is 128. So when you add it together, you get 3, 11. 11 plus 16, 27. 27 plus this is 155. So this is how you convert from binary to decimal. Okay? This is how you convert from binary to decimal. Now, do we look at hexadecimal? Let's see. Look at hexadecimal. You have to divide what? By 16. You have to divide by 16. So let's say you want to convert decimal of 414156 to hexadecimal. So you take your number, remember 12. Now 259 you have divide by 16, you have 16 remainder 3. 16 that you got the quotient, divide by 16 is 1 remainder 0. You now take the 1 divide by 16, 0 remainder 1. Now if you now take the arrow up again, you have 1, 2, 0, 3, 12. 12, remember 12 is equal to what? Remember, after 9, you know, we have A is 10, B is 11, C is what? 12. So that's how we assign this one as C. This 12 is C. So we have to take it as 103C. So this is the hexadecimal equivalent of 4156. So you need to know how to do these conversions, because you know your questions will be multiple choice questions in the exam. So you need to know how to convert from one number system to the other number system. So make sure you learn everything here. You understand how to convert it in your the textbook for this course. You need to know how to convert from binary to decimal, convert from decimal to binary, decimal to octal, octal to decimal. They are all here. It's the same procedure I explained that you are going to follow through, and you get it. So make sure you understand it. Now, okay, another thing, could you type your questions? Those of you raising hand, could you just type the questions, please? Type your questions. Type the questions for me. Okay. Those of you raising hand, can you raise up your hand again? Because you might not. Can you raise up your hand again? I'll call you now. Yes, I'm going to send slides. Okay, I should come again on the binary. I can send slides. Maybe after this class, I can just drop the slide here for you. What is the recommended textbook? Oh, there is a textbook recommended for the class now. This is the 6th class, and a lot of people have been coming to buy it either from the bookshop or from the department. We have recommended book for this class. Abbas, please, what's the name of the book, and what room number can they get the book in the department? Yes, you can convert 0.625 to binary, but there's a way to go about fraction conversion. You
room
can
14.
convert room 14. Okay, go to room 14 in the Department of Computer Science, ground, I think is it ground floor on that? What level?
Ground floor, ground floor.
Ground floor, ground floor. I'm going to type here, ground floor,
14.
room 14, Department of Computer Science. That's where you can get the book. That's where you can get the book. Yeah, the textbook, you're asking me if it's compulsory. It's for your own good, because it will guide you with more examples, and you will see some practice questions, and there's a logbook. Mr. Abbas, I think there's a logbook too for assignments.
And the logbook is for your CA. So the logbook comes with the textbook, and the CA is 30 marks. So that should tell you the implication of not getting the textbook. That's if you are ready to forfeit 30 marks for your CA. You'll be given an assignment in the 8th week, which is going to be a programming assignment that you must attempt or solve in the logbook. So it is the logbook for you. You might decide that you don't want to get it, but it's at the expense of 30 marks.
Did you all hear what Mr. Abbas said? We have a logbook which comes with the textbook. If you go to the, I'm writing it again, Department of Computer Science, of Computer Science, room 14, ground floor. I know some of you came. This thing keeps going to records.com. It's not going to everyone. Let me select everyone and post it to everyone. Everyone in meeting. Okay. Yes, I've sent it to everyone now. I've sent it. That's where you can get the book. That's where you can get the book for the course. Okay? That's where you can get the book for this course. Like Mr. Abbas just explained, the textbook comes with a workbook and some past questions and with plenty examples, which you can go through and see exactly how the past questions are structured. It's going to guide you. You'll be able to practice better. And 30 marks is awarded for the practical, for the assignment, which you are going to submit. You'll be given assignment and you have to submit it via the logbook, and that accounts for 30% of your for your exams. So it will be your own interest to get the book. So many people are posting things. I'm not even able to read everything. Let me see. Any other question? Is everyone? So some people are not hearing me. I'm speaking out so much loudly. If you can't hear me, don't worry. Maybe I'm going to just share the slides right away so that everybody can have it in this class, because getting everybody at the same time is pretty difficult. Let me share my slide, but it doesn't prevent you from buying the textbook. My slide is just my personal slide. The book is still the final authority, which you must get to help you solve your assignment and get your scores. About those people who raised their hand, can you see them? Yes, I've seen them. I've seen them. All right. Those who raised their hand, can you help me? Can you help me unmute them? Yes, I'm trying to unmute them one by one so I can speak with them. All right. Emmanuel Bajobi, you have been unmuted, so you can speak.
Good morning, ma.
Good morning.
Can you hear me?
Yes, Emmanuel, good morning.
Good morning.
I can hear you, Emmanuel Bajobi. Hello, Emmanuel, go ahead.
Hello, ma.
Hello, good morning, Emmanuel.
Emmanuel, speak. Ask your question.
Where can I get the book and the textbook? How much is it?
I don't know how much they sell it, but I've posted where you can get it.
Ask your colleagues. Some of your colleagues have bought it already, so you should find out from them. And I think you should stop asking about the textbook. You can ask your colleagues that have gotten it so that the lecture can proceed.
Besides, I have posted where you can get it, ground floor, room 14 in the department. I've posted it right here now. I've posted it like 2-3 times. I've posted it, Emmanuel. I've posted it. Mr. Abbas, please unmute the next person. Yes, I can post it again if you want. I'll post it again because of you. Just watch, you see it now. I'm posting it again now. It's there. Everyone, okay. I'm selecting everyone. You see it now. I've sent it now. Department of Computer Science, room 14, ground floor. That's where you can get the book. It comes with a log. Okay. Okay. Now, Abbas, you can unmute the next person. Let me speak to the next person. Hello. 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 Have you unmuted somebody? The next person, Mr. Abbas. Hello. Have you unmuted the person? Okay. Well, if it's difficult, let me continue with the class because my battery is going down and time is going. My data is eating up. The next, we're looking at how data.
Hello,
yes.
Ma. Hello, Ma. Good morning, Ma.
Good morning, ma.
Please, Ma, can you re-explain the text code and the bits again, Ma?
I won't be able to repeat everything. I will send the slide, you will get it. In fact, let me try and share the slide now. If I share the slide, you will get it. Because I won't be able to, I need to explain another thing, the third thing. There are 3 forms in which data is represented. I've talked about the numeric ones, which consists of the binary, the octal, the hexadecimal, and then the text code, which is made up of the different forms, ASCII, extended ASCII. I can't, you want me to go over the binary and the text code? No. If I give you my slide, you will get it. Let me share my slide. It makes it easier for everyone. I'm sharing my slide now. Once you go through it, you will get it. What's your name? Next one. I'm sharing my slide now with you. Data representation in computers. Okay. I've sent it now. Can you see it? Can you see it? I've sent my PDF. It's there. The patient is loading. The patient, you're going to see it. It should drop at your end. Because practically it means you're asking me to explain everything I've done. I've loaded it now. I've uploaded it. It's going to drop. Maybe it's network. I can't see it. Nobody has seen it. Hasn't sent. Seen. Somebody has seen it. The patient is going to drop. We know we'll have different networks with different connecting capabilities. So somebody said he has seen. Somebody, okay, more people are seeing it. Agbetile, Toluwashe has seen it. Twins have seen it. So people are now seeing it. So be patient. I've sent it to everybody. It's going to drop. So the lady who spoke to me now, if you are patient and you go through it, you are going to understand the binary and the text code I explained. I know you didn't get it, everything. Don't worry. Go through it, you will get it. I try to make it so simple. When you go through it, you understand it, and then go to your textbook, you'll get everything easily. Okay? Just check this, your chat space. You are going to see it. Some people are seeing it. Please, those who have seen it, post it in your departmental group chat, or if you have a faculty group chat, post it there so that others can see. An image. Oh, he said it's an image. It's a PDF. It's a PDF. Let me look again. He said it's an image. Okay. It's not supposed to be an image. Let me see. Image. FSC 113. Okay, I remember. I've not converted it to a PDF. Sorry, it's in Word document. Okay, so let me just quickly convert it to a PDF and send to you. It's in still Microsoft Word. I've not converted it to a PDF for you to access it easily. Okay, you get it now. Sorry. I thought I'd converted to a PDF. It's not yet in PDF format. It's still in Word. So I'm converting it right away and you get it right now.
Are you progressing?
Yes.
That's the first button for that. One.
Network is slow at my end. Can somebody drop his phone number in this class? Can I get one number so that maybe I can send it via WhatsApp and you can post? Because network is fluctuating at my end, please. Okay. Who is a governor here? I think I prefer a governor. Okay. Trust Babalola. Can I deal with you? Trust Babalola? Because you were the first person who responded. Oh, okay. Okay, Trust Babalola. Let me deal with you. Trust, once you get it, yes. Trust Babalola. I think I like. Send me your number again, Trust. Everybody should just stop. Okay, I'm class rep. Boluwatife Akintola, what department? Class rep. Boluwatife, what department? Send me your number. Pharmacy class rep. Do you have a general WhatsApp group for everybody? Do you have a WhatsApp group for the whole of you? Hold on, you are typing too fast. I'm unable to pick it. Hold on, stop typing now, please. The numbers, they are disappearing. I just want to pick a few I can send. Calm down. Do you have a WhatsApp group for everybody? No. For the whole, you know, you are from the whole university now. You're not from one department. I need to explain the third type. Okay, I think let me do this way. Let me quickly finish up the third type of formatting which data is represented, and then I will pick some numbers here and send it to you by WhatsApp. Okay, let me quickly wrap up the topic because time is going. My computer battery is low. I don't have light where I am. I have 30%. So let me finish the topic, after which I will now send it to you immediately. Let me finish the topic first. I will attend to you. Okay. Okay. You have a group for everybody, right? That means there's MSA group, which is for everybody. Okay. 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 Now the third formatting which data is represented is byte and bit. Remember, I've talked about numeric format, which made up of the binary, hexadecimal, octal, and decimal. I've talked about the text code format, and now the next one is the byte and bit. So data is represented in the form of byte and bit. Now, what is a byte? A byte is the smallest form in which data is represented in your computer. It's just similar to what atom is. An atom is in chemistry. You know, an atom is the smallest indivisible particle of an element or a molecule. So the way what an atom is in chemistry is what a byte is. So a byte is the smallest form in which data is the smallest unit in which data is represented. So a byte is either the 0 or the 1 used in digital data representation. The zeros and 1 used to represent digital data refers to as the binary digits. Okay, so it is from this 10 binary digit that the word byte is got. The B and then the IT forms the bit that stands for binary digit. The BIT here is coming from this B here, this first letter B, and this IT here, binary digit. Now, it's the smallest unit in which data is represented, which is 0 or 1. So a group of 8 bits is called a byte. Okay, a group of 8 bits is called a byte. If you look at this table here, look at it. Each of these 0 and 1 is a bit. A bit is the smallest positive unit of data that the computer can recognize or use. So look at it. 0 is a bit, 1 is a bit, this one is a bit, you know, this one 1 0 1 1 0 is a bit. So computer usually uses bits in groups. So that is, it lumps these zeros and 1 in groups. So for this one now, 8 of it, 0 1, we have here 1 2 3 4 5 6 7 8. We have 8. This 8 bit is equals to 1 byte. Okay, 1 byte is equals to what? 8 bits. Okay, so we use now 1 byte is equals to 8 bits. Now the following table shows the conversion between bit and byte. 1 byte, like I said, is equal to 8 bits. That means zeros and 1 in 8 places, arranged in different patterns. Then 1000 bytes is equals to 1 kilobyte. Then 1024 kilobytes is equal to 1 megabyte. 1024 megabytes is equal to 1 gigabyte. 1024 gigabytes is equal to 1 terabyte. 1024 terabytes is 1 petabyte. 1024 petabytes is equal to 1 exabyte. 1024 exabytes is equal to 1 zettabyte. 1024 zettabytes is equal to 1 yottabyte. 1024 yottabytes is equal to 1 Brunto byte, and so on. So you need to know the conversions, because you might be asked how many bytes are there in so number of, let's say, kilobytes or megabytes. So you should be able to know this conversion table and calculate it out to get your own value. Now, what else do I have to explain here? What else do I have to explain here? Okay, I think that explains what I'm trying to say, that there are 3 formats in which data is represented in computer. It is represented in numeric. If it is numeric data, we can use the binary, the octa, the hexadecimal, and the decimal format. This one up here that I talked about. I talked about it here. Look at it. It's the first one I talked about. Look at it. Numeric numbers are categorized into 4 types. This is it here. So for number system, you see, when you are talking about numbers, we have binary, octa, decimal, hexadecimal to represent them, and this is it. And then you can convert from one number system to another type of number system. And then if you're talking about the text code, which consists of characters, when you're talking about characters, alphabets, and other symbols, you use text codes format. And then the popular text code systems are EBC, DIC, ASCII, extended ASCII, and the Unicode. Then we have this is the way in which data is represented, the text is represented. Now we have conversion from one, I've mentioned this, you can convert from one to the other. And then the other third format of representing data in computer is by use of bits and bytes, which is zeros and ones, zeros and one. So if you actually look at it, if you look, even this one too, everything is actually in bit and byte, because if you're in your binary, you're already talking about bits and bytes, and then your text format here, you're talking about. So the main deal is that numbers, text, everything is represented as bits and bytes in computers. That is just a summary of it all. So you should be able to understand this basic fundamental of how data is represented in a computer. Okay. So I think that's that. Remember to be able to calculate from one number system to another, from binary to octa, from octa to hexadecimal, and all that. You see all the examples in your book and past questions. So that will guide you on how to prepare well. Now, like I was saying, let me see if I can convert this thing now and give you. I guess it's not going because I'm probably it's because I'm screen sharing, because I've tried to save it several, it's not going. Let me stop sharing this screen and see if it will go. Because I've tried severally to convert to PDF, it's not good. So I guess it's because I'm screen sharing. Let me stop sharing the screen. Stop share. I think when I stop screen sharing now, it's going to get converted because I've tried receiving it as a PDF and it's not being accepted. So let me now save it as PDF. Now I'm no more screen sharing. I'm sure it's going to go. It's not responding. It's not responding. Do I send it by email? Do I send it by email? My internet connection is unstable. It's unstable. It's not cooperating with me to receive it as a PDF. Okay. Maybe I should send it via WhatsApp to somebody now. Okay. I don't know. I don't want to drop my number, because if I drop my number now for somebody to send me hi, I'm going to have, okay, let me pick one person and send it to that person. If I drop my number now that somebody should send me hi, I will be in trouble. So let me pick somebody's number, save it and send to that person. Boluwatife, you are a class rep. Hold on, I saw Bolu. Let me take Bolu's number. Please stop sending messages. Oh. Boluwa, resend your number. Boluwatife. Boluwatife, resend your number, please. Okay. Please, nobody should type again so that it doesn't disappear. Somebody. I said nobody should send anything again now. You students don't hear. We We don't need to record again. Abbas, you can stop. We don't need to record. I've actually stopped explaining. Yeah. Please, Boluwatife, send me your number. It's disappeared. I was typing in 08. Okay, I've seen it. Don't worry, Boluwatife. 11-407-0747. Okay. Okay.
Should I stop the YouTube
Recording.
live streaming?
Yes. You can stop the live streaming.
Class has ended.
Yes, but I want to send something to Boluwatife who will help me distribute it.
Okay, all right, man. So let me.
That's what I want to do. Don't end. Wait, so that they will all be aware that Boluwatife, even those on YouTube, they will now hold Boluwatife responsible.
Okay, all right, no problem.
Don't end yet. Hold on. We're almost done. Because I saved it as PDF so that I can carry it and put. It's not coming out. And the Word document, they said it's coming out as it's coming out like what do you call it? Like an image, which I wonder why. Okay. 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 It's on that document. Okay. That document. Okay. 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 Oh, I found the problem. The part, the folder I thought I put it wasn't where it was. I put it in document. I didn't put it in the folder I've been checking wasn't the right folder. I've actually saved it severally, but in another part, which is my document, which I don't normally put things. I don't put things in my document. I have a folder for this course. So I didn't know I didn't put it in the right folder. So you are going to get it now. You will get it now from me. And that document. Okay. That document. On that document. Document. Okay, I've seen it. Wow, I've seen it now. Okay. Guys, check from your end. You should have it now. You should have the PDF now. Please reply if you've seen it. I've seen the right folder. Has everyone seen? It's there. Be patient. Seen. Trust Babalola has seen it again. Trust Babalola has seen. Bamileri Alonge has seen. So that's my PDF. It's going to drop at your computers. Be patient. Adigun Oluwa Darasimi has seen. Adigun Oluwa Darasimi has seen it. Faith. Agbetile Toluwashe has seen. It's going to drop at your end. Don't worry. I've sent the PDF now. So that's okay. So let's call it a day. Enjoy the rest of the day. Thank you. Class ends. It's going to come. Just be patient. I won't just remain connected. It's going to drop at you. And don't log out yet so that you can see it. I have sent it and everybody is seeing it. It's going to come. Be patient. Those who have seen it, please post it in your departmental group chat and spread it. It's just a guide anyway. It's a rough guide, but make sure you read the textbook. Read the textbook so you can understand it more and see more examples. It's in the chat. I dropped it in the chat. It's in the chat. I'm sending it again. I've sent it again to the chat, so it's still to drop again. I've sent it to the chat again. It will drop again now. So I've sent it second time. All right. So those of you who have not seen it, just wait. It's going to come. Those who have seen it, please spread it. Drop it in your group chat, and so that it can spread around. Thank you. I sent it here via, there is a drop down button here where you can select your file and send it. I sent it via the chat. Look at your chat here. Look at your chat. You will see it. Some people have seen it. A lot of people have seen it. I sent it to everyone. I selected everyone. I sent it twice to everyone. I sent it everyone. There are options here. So I selected everyone. So I didn't select to a few people. I selected everyone. So maybe due to network, it didn't drop at your end. Check your chat. Check your chat section. It will definitely drop. Sorry if you didn't find it. Those who are using laptop will find it. There's nothing I can do. I said, those who have seen it, please send to others. So please, okay?
Ma, has the class ended?
Yes, please, Abbas, it has ended.
So do I have to close the meeting or?
Those who are yet to, I think you should, they would have seen it. Those who have seen it, please, those who have seen it, you share it. Trust, Baba Lola has shared it again. Baba Lola Trust, thank you. Baba Lola Trust, put it in your group chat. In your group chat. And those who have seen it, spread it to other people in their other classes, your other friends. Spread it, okay? Abbas, I think we can end the class.
Okay, ma, I'll be doing that immediately.
All right. Thank you very much.
Yes, ma.
Thank you. God bless you.